Hi, good afternoon, and welcome to the third seminar of the Civil Engineering program. We're very happy to have you all here. I'm Larissa. I'm a PhD student at this program. I'm going to be your host. And this year, our event is going to happen 2 days. Today, of course, next Monday, November 23rd. So don't forget. This is an event that dares to go beyond the domains of the university, connecting the academy to other productive sectors. And this year, we're going to be talking about science, entrepreneurship, and leadership in engineering. Just a quick warning to the Portuguese speakers. Para quem quiser assistir esse evento em português, tem um outro link com tradução simultânea no canal do PPGEC. É só dar uma olhadinha, tá bom? We'd like to thank our partner and sponsor, Cornélio Brennan Group, for always supporting our event. And if you haven't already, please subscribe to the channel, give us a thumbs up, press the bell, and stay on top of what happens in our program. So let's start by inviting a few people to our virtual opening table. I'll invite all of the table members, and then I'll give the talk to you. I want to welcome Professor Leonardo Meira. He's graduated in civil engineering by the Federal University of Pernambuco, has a master's and a doctorate in civil engineering in the area of transport and urban infrastructure management. He's the current coordinator of our graduate program. Welcome, Professor Leonardo.
Thank you.
I am proud to introduce, representing the student body, Paulo Souza. Paulo has a bachelor and master degree in civil engineering from this institution. He's currently a PhD student in civil engineering in the area of structures, developing research on reliability analysis in pipelines, focusing on maintenance planning. Welcome, Paulo. I'd also like to invite Sérgio Cavalcante, Director of Innovation from Cornélio Brennan Group, representing the industrial sector, which is sponsoring our seminar. He's graduated in electrical engineering by the Federal University of Pernambuco, has a master's in computer science and a doctorate in electronic engineering from the University of Newcastle upon Tyne in England. Welcome, Sérgio. Now, I invite the Dean for Post-Graduation of our university, Professor Carol Leandro, also representing the women in science in this table. We're very proud of that. She's graduated in physical education by the Federal University of Pernambuco, has a master's and a doctorate in sports sciences from the University of Porto. She's also a member of the Pernambuco Academy of Science. Welcome, Professor Carol.
Thank you.
I invite the Vice Rector of our university, Professor Moacir Araújo. He's graduated in civil engineering from the Federal University of Pernambuco, has a master's degree in hydraulics and sanitation by the University of São Paulo, and a doctorate in physics and chemistry of the environment by the National Polytechnic Institute of Toulouse, France. Welcome, Professor Moacir. And finally, I also invite Professor Alfredo Gomes. He's graduated in psychology, has a master's degree in sociology from the Federal University of Pernambuco, and a doctorate in education from the University of Bristol in England. He's currently the rector of our university. Welcome, Professor Alfredo. This is the second year that Cornélio Brennan Group sponsors our seminar, but more importantly, is the group partnership, which contributes to institutional and human resources development throughout science. Thank you all for being here. I would like to remind you that our guest speakers, Professor Elizabeth Edwards and Emily Moore from Canada, are already in the backstage and are listening to us. And I will give the word now to the chair of our graduate program of civil engineering, Professor Leonardo, please.
Thank you, Larissa. Good afternoon, everyone. Initially, I would like to welcome the presence of UFPE Magnificent Rector, Mr. Alfredo Gomes, our Vice Rector, Mr. Moacir Araújo, our Dean of Research, Mrs. Carol Leandro, Mr. Sérgio Cavalcante of Cornélio Brennan Group, and Mr. Paulo Souza, our doctoral student, on behalf of which I greet everyone who is watching us today. The Seminário Integrador is a remarkably successful event at UFPE, and we are immensely proud of it. It starts its third edition today, and thank God the feedbacks from the two previous editions are the best possible. It is an event held annually by students, professors, and technicians with great participation and enthusiasm. It is done with dedication, love, and above all, competence. The Seminário Integrador has been a forum for bringing graduate students and the academy closer to professionals, to companies, and to society. The theme of this year's seminar is Science, Entrepreneurship, and leadership in engineering. As a public university, it is important to awaken this type of interest in people, to make it clear that the university has the power to train scientists, entrepreneurs, and people who will make our society move forward, be more plural, and more present in the daily life of our cities. Therefore, the graduate program in civil engineers fulfills this institutional mission by promoting debates, by instigate exchange of experience between renowned professionals with younger people, and by offering a healthy and respectful environment for exchange ideas. We all know that we live in a typical year, a year of challenges, a year with great losses, and they must never be forgotten. However, it is also a year of learning in life, in the university, in science, and in human interaction. Consequently, our seminar has to be done this year in a virtual way. That was a small adaptation that the moment demanded. Yet, I would like to highlight that the program, as always, is full of interesting themes and worldwide known speakers, like Mrs. Emily Moore from ILEAD, Mrs. Elizabeth Edwards from University of Toronto, Mr. Roberto Guerra from DINI UFPE, Mr. Jones Albuquerque from LICA, and Mr. Altigrande Soares from University of Amazonas, to whom we are incredibly grateful for having accepted our invitation. I am sure they will certainly brighten our event. We will have oral presentations of our students' work and a 3-minute competition where the students will have 3 minutes to present their research project, and there will be a popular vote to choose the best presentation. Finally, I must say my greatest thanks to the tireless work of the entire organizing committee, composed of students, professors, and technicians. I will not nominate one by one, but please, everyone feel embraced and congratulated. Your work, once again, was sensational in the organization of this 100% virtual event. Therefore, I invite everyone to attend the event, the presentations, to share experience, and to increasingly enhance our Seminário Integrador. Thank you all.
Thank you, Professor. Now, representing all of our 400 students, including myself, Paulo, please.
Thank you, Larissa. Hello, everyone. Good afternoon. I wrote a very little speech just to talk a little about my experience as a student in the organization of this integrating seminar. So at first, I really have to everyone in this virtual opening table, Professor Alfredo, Professor Carol Leandro, Professor Leonardo Meira, Professor Moacir, Sérgio Cavalcante. Thank you all for accepting our invitation to compose our virtual opening table. And first, second, I have to say that it's a great honor and pleasure to be here representing all the students of our program. And now I'm currently in the 3rd year of my PhD research, but I also got my master's degree here at the program. So I have been studying here at the program since 2016. And I have been helping in the organization of Integrating Seminar since its first edition in 2018. Our first edition was a huge challenge because everything was new. We didn't really know what to expect. Everything was new, different, but we managed to create a really good event. And as Professor Leonardo said, a very interesting event that has been happening now for 3 years. And in first edition was a huge success. So in second edition, we had a really big challenge to make it even better than it was first edition. So from the first to the second edition, we had a large increase in the number of participants, in the time of the event. Our first edition was 1 afternoon. Our second edition was the entire day. So we had a really significant increase in the number of participants, in the number of speakers, and we also had an increase in the number of presentations from the students. So our expectations to the third edition, the 2020 edition, this year's edition, were really high. We were expecting to create a even bigger edition with more participants, with more time. And then coronavirus pandemic came and surprised all of us. But even with all the difficulties and challenges that we were facing, we managed to organize the first ever online edition, which is this one that we are presenting right now. And I'm really, really happy to see that the outcome results. This year, in addition to the international and national speakers, we will also have competitions between students from different areas. The 5 minutes competition, which will happen today, the 3 minutes competition, which will happen in the next day on Monday, the second day of the event. Well, just to end my speech, my very short speech, I have to say some really, really special thanks. So first of all, I would like to thank everyone who helped us to get here and build this event. I need to say some really, really special, huge thanks to all the professors who have been helping us. Professor Sávia Gavazza, Professor Leonardo Meira, Professor Anderson, Professor Bruno Soares, Professor Bruno Magnus, and so many others who have been helping us. I also have to say a very, very special thanks to all the students, the student body, who have been helping. And I'll say just a few names: Wilson, Carini, Larissa, Julio, Aila, and some others who have been helping us. I have to say a huge thank you for the partnership in the organizing committee. And last, I have to say a really special thanks to all of our national and international speakers. Thank you for accepting our invitation to be here talking to us, sharing knowledge, and thank you for believing in our event. And finally, thank you all of you who are here watching us, who put our event in your schedule and are here honoring our event. It's a great pleasure, and thank you all. Larissa, back to you. Thank you, everybody.
Thank you, Paulo. Now, I'd like to give the word to Sérgio Cavalcanti from the Cornélio Brennan Group.
Thank you, Larissa. Good afternoon, everybody. It's a pleasure to be here. First, I'd like to salute all my colleagues from the opening panel, Paulo Souza, Carol Leandro, Vice Chancellor Moacir Araújo, and our Chancellor Alfredo Gomes, and a special thanks to Professor Sávia Gavazza and Leonardo Meira, who invited us to be here with you again. It's the second time we sponsor this event. It's really a pleasure to be here representing Group Cornélio Brennan in this connection between the university and the market and the industry. This year is even more special, this kind of event. This connection needs to be made even closer. No? We have a social distancing, but at the same time, this social distancing brings an economy of empathy. We have to be empathetic. We have to look at each other in another way. More than ever, we have to need a close look to connections, partnerships, to our neighborhood, to our clients, but our suppliers as well, to the society in general. We have to have a closer look to ESG. I don't know if you know this abbreviation. It's environmental, social, and governance, things that companies are looking deeply nowadays, and even closer because of the pandemic. I think we need to keep closing the relationship between academia, industry, and society in general. This event is very important to do this. It's very important to our university. It's very important to our society to close together and solve problems from society in general. We are really happy to sponsor this event, and I know it's going to be a success. Thank you very much.
Thanks so much, Sergio. Thank you to the entire Cornélio Brunner Group for this partnership. Now I'd like to give the word to our Dean for Post-Graduation, Professor Carol Leandro.
Hello, thank you very much, Larissa, for the presentation. I would like to first greet for our rector, Professor Alfredo, and our Vice Rector, Moacir Araújo, and their name to greet all the members of these initial works. So I also welcome for our guests, international guests, Dr. Emily Moore and Dr. Elizabeth Edwards. I wish you could come to Recife as soon as pandemic goes to the end, and then you can see all the people in person. That is very important. I think this meeting, led by researchers from the graduated program on civil engineering, brings out an important thematic for the 21st century, not only to allow collaborative projects between UFPE and other universities, but also to develop a sense of shared purpose across the science involving the area of engineering. I believe that this project belongs to CAPS Print, as Savia confirmed before. And that is one of the most important institutional programs to improve internationalization for Brazilian universities. And we have a great program for the moment at UFPE. And we all know that the pandemic has not allowed the visiting person to the labs and the student and researchers' mobility. As all my colleagues before talking about the challenge, I also talking about this challenge. But this is good because this is a time for a remarkable change that put the globalization process in questions. And the immediate solution is now devoted for the technology. UFPE is expanding dramatically in some strategic fields of research. We can recognize this process in the area of civil engineering. Both courses of undergraduation and graduation are presented in two campi at UFPE, one in Recife and the other in Caruaru, around 140 kilometers from the littoral. This is a way to admit more state-educated students, and is producing research that has a commitment to the environment and our society. As we can see, the involvement of UFPE with the Sustainable Development Goals 2030 agenda. To finish, I'm well aware that science is facing a hard time with political extreme position, and the consequences is directly related with change to the way it's founded, the way it's governed, and how it is evaluated. But I'm also sure that we are able to manage this complex moment in the history once we are strengthening collaboration across national borders and disciplinary boundaries. I strongly believe that our main goal will remain focusing on the unstoppable force of the promotion of an education that is inclusive, transdisciplinary, and committed with the society. Thank you very much, and congratulations to all that were in front of this important meeting.
Thank you so much, Professor. Now I'll give the word to the Vice Rector of our University, Professor Moacir Araújo, please.
Hello. Thank you, Larissa. Do you hear me? I think, yes. So, yes. Good afternoon to everyone. Maybe good morning. I'm not sure for which longitude I'm talking to, but anyway, I'm very happy to be here. First, I'd like to thank the invitation. Thank you, Savia and Professor Leonardo as well for this afternoon, this nice meeting that is starting now. So the third meeting, it's already some hours on the road. I'm very happy to be here. In fact, as mentioned by Carol Leandro, and even with the talk to Sergio, our sponsor representative, it's very important to take some advantage concerning the pandemic time that you are living now. I know that we have a lot of new problems for the all health and anyway remote every time with virtual meetings and so on, but we have also new opportunities. So we should get it in the agenda, and it should improve our relationship, not only in the national landscape, but mainly in the international landscape. So let's get all the profit we have concerning what we are doing now, and let's make the world still smaller concerning the relationship between people, between science is very important. And I would also mention that I am very happy to be here for two reasons. The first one is that we know that this meeting and all these organizations is also some kind of sign concerning the high level of research and also the scientific development of the Federal University in Pernambuco. And the second, as a former civil engineer from this university, a student, I'm not going to say how long it was, some years ago. I would like only to mention some years ago, but I'm very happy to see how fast we go and how we can do more and more for the science and for the planet. So it's very important also to rewrite the history of the science concerning this new agenda, this new planetary agenda, as also mentioned by Carol Leandro. I mean about the sustainability and also from the United Nations 2030 agenda with the Sustainable Development Goals. So we are more than ever as a university aligned with this kind of agenda, and we improve more and more. So we should, this is just a little bit a message. We should do a less message. We should rethink our engineer, rethink our relationships, focused on the new challenges. And I think that we have people, we have a relationship, we have cooperation, we have all to do that. So very happy, thank you very much. And on behalf of the Federal University, welcome to this virtual meeting. And I wish you a very nice 2 days job. Thank you. Thank you, Larissa. Thank you all.
Thank you so much, Professor. And now I'd like to give the word to the rector of our university, Professor Alfredo Gomes, please. Professor Alfredo, seu microfone.
Do you hear me? Okay.
Yes.
Professors, students, and the staff of the university, good afternoon. It's a great pleasure that the University Federal of Pernambuco hosts such an important event. We all feel deeply honored by your participation. As University Rector, I compliment all those who organize this seminar. I would like to say I'm very thankful for the presence and participation of Miss Professor Emily Moore from the Institute of Leadership Education Engineer from Canada, and Professor Elizabeth Edward, University of Toronto. You both are very welcome. UFPE is one of the most important universities in Brazil, and one of the leading institutions in research, innovation, and internationalization. Our civil engineer graduate program has had a very active and meaningful contribution to research, master and doctorate courses in our region and in Brazil. Excellence and commitment are the words that best describe the central importance of our professors, research, and students. Coronavirus has demonstrated the importance of the university worldwide to overcome threats and crises. It is our duty to provide consistent response to our society, be it against pandemic, be against gender violence, and be against anti-science movement. It is our duty to replace science as a central role in our society. Events like this indicate the resilience, resilience perspective of our university system, both in Brazil and around the globe. It also emphasizes the fundamental dimension of discussing science in time of denial. Debating around leadership as a critical competence for the 21st century is decisive for at all times, in as much as collaborative research lessons are strong pillars for capacity building and internationalization. May resilience, leadership, and collaboration be central skills in the university curriculum, decision-making, problem-solving, and especially to prepare for and deal with unexpected events. May this event encourage collaborative and cross-cultural exchange and the development of 21st century ability. Once again, thank you everybody for your participation. I wish you all a very positive learning moment this afternoon and during all seminar.
Thank you so much, Professor. Thank you all for being here. It's an honor to have you here. Thank you for your words and thank you for contributing to our event. Só mais uma vez, para quem precisar, a tradução simultânea, né, tem outro link, inclusive dá uma olhadinha aí no chat, que deve estar o link da tradução simultânea, para quem quiser. And now, for those of you who haven't seen it, let's just take a minute and have one more look at the seminar's video. Just a minute. And now I'd like to invite Professor Roberto Guerra, the Director of Innovation and Entrepreneurship from our university, to chair this section. Let's just wait a little bit. How you guys doing today? Let's wait a little bit for Professor Roberto Guerra, and then we're gonna have, oh, here he is. Hi, Professor.
Hi, Larissa,
So
thank you.
Professor Guerra, the Director of Innovation Entrepreneurship from UFPE. Welcome, Professor. He is going to be the chair to this section. I'll give the word to you.
Okay, Larissa, thank you very much for the invitation and confidence. Thank you our earlier speakers for the beginning of this afternoon discussion. And we're very happy to be part of this experience, representing the Innovation and Entrepreneurship Affairs Office, linked to the Prorector of Research and Innovation. The audio is better now, Larissa?
Yeah, I can hear you.
Okay. So I will try again to adjust the audio. So
just a minute. Let me. Please, Professor, continue. We'll figure this out.
okay. So I think the audio is better now. So thank you for the invitation and to join you this afternoon. Thank you for our speakers that opened this afternoon work. And I'm here glad to represent the Innovation and Entrepreneurship Affairs Office, linked to our Prorector of Research and Innovation at UFPE. So I'd like to give you a brief presentation about our international speakers. The first one will be the Professor Emily Moore from the Institute for Leadership Education in Engineering, ILEAD at Canada. Thank you, Professor Moore, for joining the discussion this afternoon. So, Larissa, can you show us Professor Moore, please?
Yes.
Well, before we started, before I start, I'll give you a brief presentation about Professor Emily Moore. She was appointed Director of Trust ILEAD in October 2018. After more than 20 years in industry, she started her career at Xerox Research Center in Canada, scaling up new materials and processes. After several years in industry, she joined the academy and started as Director of Technology Development and then Management Director. Professor Moore also the inaugural chair of Hatch's Global Diversity and Inclusion Efforts, and she holds a bachelor degree in engineering chemistry from Queen's University and completed a doctorate in physical chemistry from Oxford University. In 2016, Professor Moore was recognized as one of the 100 global inspirational women in mining and received the SCI Canada Kalav Fuji Award. The title of the lecture will be Engineering Leadership, Developing a Critical Competence for the 21st Century. I'd like to ask the audience just 1 minute. We're fixing some details in our platform. Larissa, it's back to you, so you can help us to properly present the Professor Mu's screen.
Oh, there we go. Can you hear me? Okay, I'm going to look here because that's where my camera is, but yeah, that's great. I can see. Hi, everybody. Thank you very much. It's a real pleasure to be joining you today. And congratulations to the organizing committee on an excellent job. I know technology is very challenging, but one of the lovely things about this pandemic is that it has actually made the world seem smaller. So it's very exciting that I can speak to you today from Toronto, where it is actually much colder than I think it is where you are. So I wish I was there with you in person. I have had the pleasure of being in Brazil several times for work before, and so I hope that I'll get to go again in the future. I'm just going to try to share my screen and see if this will work. Let's just do this window. Okay, I think you can see that now.
Not yet.
Not yet.
Okay.
Is it through? There we go.
Yes, it's coming. Okay, thank you.
Perfect. Good, thank you. Okay, so I'm going to just put my timer on as well so I don't talk for too long. So I am from an institute called the Troost Institute for Leadership Education and Engineering. And that sits at the University of Toronto. And the University of Toronto, for those of you who don't know it, is a large public research institution. We have 70,000 students through the 3 campuses. But in engineering, we have 5,000 undergraduate and 2,000 graduate engineering students. And so the role of iLead is primarily to support our students in developing their leadership skills. And I'll talk a little bit more about our mission in a moment. So the question, of course, is why are engineers called to lead? Why do we have a leadership institute in the first place? And your deans and your rector talked about the need for engineers to be helping to lead. And this is a statement from the National Academy of Engineering over 15 years ago when they were looking ahead at what they expected engineers to be able to do today in 2020. And so they say, with the growing interdependence between technology and the economic and social foundations of modern society, excuse me, there will be an increasing number of opportunities for engineers to exercise their potential as leaders, not only in business, but also in the nonprofit and government sectors. So putting it a little more simply, the world is becoming more and more technologically complex, and the rate of technological change is very, very high. And at the same time, society is demanding increasing accountability from companies and from our profession. And your deans and your rector talked about that. They talked about the UN Sustainability Development Goals. So these are very important pieces that we need to be thinking about how to address. Engineers are equipped with great technical and analytical understanding, but they must also have the leadership skills to be able to contribute to these conversations. And I don't know exactly how you are educated in Brazil, but traditionally engineers get a lot of technical training, but very little training in leadership and communication type skills. And so the question we have been trying to answer is, how can we support our students in developing those skills? So at Troost iLead, our mission is to inspire engineering students to identify as leaders and then to equip those students for lifelong leadership development. And we do that primarily through our student programs, which are elective courses that they might take in upper years or in graduate school. Also, we have extracurricular programs that the students can get involved in, programs that support their clubs so that we can help them developing those leadership skills. But the other piece of what we do is we actually do research on how engineers lead and how they learn to lead. And we do that research both in the classroom, but also in the workplace. And I'm going to talk to you about that research today. And that research is also part of our outreach, where we work with other organizations, industrial partners, and other universities around the world who are interested in these questions. So our engineering leadership community of practice is a group of companies, all currently Canadian companies, who are very interested in these questions. And they provide us funds to do research to look at how engineers lead. And when we do the research, we, like any good researcher, we start with a research question, and then we start to gather data. But what's different for us is that we are using the tools of social science, not engineering science. So we are doing surveys, we are conducting interviews and focus groups. And then we take that data and we analyze that data. And when we analyze the data, we are combining engineers like myself who know about industry and how the profession works and how the education happens, as well as social science researchers and education specialists who bring their knowledge in, and we work together to do the analysis. And from that work, we have published over 48 papers on how engineers learn how to lead and how engineers develop and look at leadership, what engineering leadership is. We also, when we take our results, we work with our industrial partners and we kind of workshop our findings to test them out, to make sure that they make sense and that they resonate with the with the work of our partners. And by doing that, we're able to build tools like case studies or special inventories or workshops that we can use both in the workplace, but also in the classroom. Sorry about that. My phone just went off. So I'm going to talk about two stages of our engineering leadership project. The first stage started in 2011, and you may recognize a couple of the industrial partners who participated with us. The Vale has a presence in Canada, and so Vale were actually one of our partners in this work. We did focus groups and interviews with our partners on how they saw engineering leadership. And then we did qualitative analysis that was led by our social science and education specialists, and our findings were tested in large-scale quantitative surveys. So the first question that we asked people in these interviews and focus groups was, how did they think about leadership? And the researchers were surprised by the results, because we have just started an institute on engineering leadership. And what we heard very clearly from the engineers was that they didn't see leadership as a very important part of engineering. So let me explain. Here are some quotes that were received. So a typical quote: "To me, leadership has kind of been polluted by the business world." The connotations that this word carries is sort of antithetical to the engineering mindset. The notion of standing on top of the hill, sitting on your horse with the peasants behind you, is the exact opposite of anything I personally or anyone I know wants to do. It's not a leadership profession. It's not a profession from which you get leaders. It's a service profession. So we kept hearing again and again this resistance to the idea of leadership as an important part of engineering, and that the emphasis in engineering was on professional service and also on working in teams. And the idea of leadership was seen to be a business concept, not an engineering concept. And yet we know that there are many leaders in the world and leaders in the companies that we were talking to who are engineers. And so we asked the question a little differently this time and asked the interviews, who are the leaders in your organizations? Who do you look to for leadership? And how do they demonstrate leadership? And we got slightly different answers this time. It all comes down to problem solving. Engineers want to solve problems. We are trained to be in the optimum, to calculate the optimum and to improve everything. Engineers are a strange dichotomy of creativity and systems. On the one hand, we say you will follow the regulations and you won't deviate from the rules. But on the other hand, we are the creators, and creators have got to, by their nature, go beyond these rules and regulations. So we're hearing here about some ways that engineers solve problems, they demonstrate technical capability, they make things better, and they push the envelope of they push that innovation envelope of what we need to do. And so the researchers came up with 3 engineering leadership orientations, 3 ways of talking about leadership in a way that made sense to the professional context of engineering. And as I go through these, I'd encourage you to think about which ones of these maybe speak to you the most or you've seen the most. So technical mastery, these are the leaders who have really deep technical expertise. They may be the professors that you look up to. In industry, they may be those subject matter experts that everybody goes to when they want to know how to deal with a really difficult technical problem. And when these people are leaders, they're not just the repositories of knowledge, but they also have a very important role in influencing the way that the organization acts towards their technology, how they're the stewards of the technology. They set the technical standard, and they do that very much through mentorship of others, through leading through mentorship. Another orientation is collaborative optimization, and this really reflects the fact that engineers tend to work in teams, and often multidisciplinary teams. So people described these leaders as people who were very good at making the process work better, making the project work better, bringing the team together, and often acting as the team catalyst, the way that things became better and worked faster. They were the people everybody wanted on their team. And the third orientation to leadership were the people who did organizational innovation. These were the creators, the entrepreneurs, the people who took the organization in new directions. They were the people that pushed those creative boundaries and said, I think we can do this better, but I also think we can do something new. And they created new offerings, new products, new services behind them. So they had this combination of the idea, but also the realization and the implementation in that organizational sense. So these were these 3 ways that engineers saw leadership around them, and 3 ways that when we went back and tested these with our partners, they said, yes, that feels like what leadership looks like in engineering. A key point here is that all 3 of these orientations blend technical and social elements. So if you're going to just simply be a leader from a business sense, without that foundational engineering and technical piece, then you're not doing engineering leadership. Maybe you're doing business leadership or something else. And so all 3 of these, that ability to meld that technical and that social that we talked about as the calling for the engineering leader was really, really important. So the second set of research that we did looked at a slightly different leadership question, which was, how do engineers learn to lead over the course of their careers? And we started off looking at students, how students learned, how young engineers learned as they transitioned to the workplace. But in the research I'm going to share with you today, we actually conducted career history interviews with 29 senior engineering leaders. These were people who were recognized by others in their field as great leaders in a whole bunch of different roles. And we used career history interviews because it's a way for us to help these people look back and think through important transitions, important moments in their career, and then really examine what they learned from each of those moments and how those moments happened, in the hope that we can get some insights that we can share with younger students and help them to kind of follow in those paths. So others have written about leadership learning, and the good news is leadership is something that can be taught, and leadership is something that many people develop over time. Leaders, some people may be born with a talent or an aptitude for leadership, but we at iLead really believe that anyone can be a leader. And as engineers, we are all called from time to time to step up into leadership. So there are 3 ways that we look at leadership learning. One is leadership training. This is when you are going in, perhaps you're becoming a manager for the first time, and you need to have some formal training on how to fulfill that role. And so there may be some specific skills and competencies that is really very much matched to the role. And many industries will put people through leadership training type activities when they go into those formal roles. Leadership education is maybe a little bit more foundational, but it's still formal. And leadership education is really what my day job is, teaching engineering students like yourselves how to develop those leadership skills, whether it's presentation skills, whether it's how to build better relationships. We work on those in our classroom through a series of a formal education process. But what we were looking at in these interviews was the 3rd type of leadership learning, which is leadership development. And this kind of leadership is tacit or silent. It happens because you're learning by doing. You're learning while you're busy doing engineering and practicing other things. So it's situated in practice. And what we found was that engineers learn to lead in 4 ways. One is that they learned from proud moments. The other was that they learned from struggles, from overcoming obstacles and figuring out how they were going to get around them. They learned by looking to others for inspiration and advice, whether that was through mentorship or role models. Sometimes the role models were people that were outside of their realm entirely. One of our leaders loved tennis, and he looked to the tennis stars of his youth and the way they handled themselves, the way they trained, and they were his leadership inspiration. And then but all of these leaders, one of the things that they do extremely well is they integrated those learnings into their professional day-to-day practice. They didn't just sort of have those proud moments. They had somehow figured out how to integrate it and how to change themselves and their organizations. So in the interest of time, I'm just going to share the learning that we've done around the proud moments. And I'm going to give you some examples from some of these various career interviews in the hope that you might say, hey, I've had a proud moment like that, or I can relate to that proud moment, and that you can then help start to integrate those learnings you are already having into your own development. So here's an example of a very full proud moment description from Steve. All of the names are changed to protect the people we interviewed. But Steve said, what made me feel proud was that we were able to turn around a really bad situation and make it into a success. It was something that ended up being discussed at the board of directors level. I knew that we could do better. There were a few key individuals that I knew could really help. I was able to dictate who was going to be on the team to go with me. It reinvigorated my career and got me back into a leadership mindset. It also helped return discipline to our technical teams and reflected well on the company and helped us improve our relationship with the plant. So this description actually captures every single salient point, every single key thing that we saw in the proud moments when we looked across the 29 leaders. There were certain things that came up again and again and again, and all of them are in Steve's example. First of all, he was facing a complex technological problem that he was trying to solve. The answer was not easy, and he could not do it alone. He had institutional support. He was given this task, but he was also given the resources that he needed to accomplish the task. He was able to choose the people that he needed for his team, and the institution, the company, made those people available to him. The contribution that team then made was seen as significant. It added on to what the company was doing already, and it was celebrated as a success. There was external recognition. The company actually celebrated it. It was seen all the way up to the board of directors. And this whole experience had a really profound impact on Steve as an individual, but he also tells us that it had a big difference to his team and to the company. It made a change at a much bigger level. So this proud moment that Steve describes, it has aspects that we see across many of the proud moments. The researchers were able to divide up these proud moments into 4 different types. And again, as I go through these examples, I hope that you might think, oh, I think I've had a proud moment that feels a lot like this. So the first one is professional dexterity. And this is an example where the individual has been able to overcome a very difficult technical problem. And as I know that most of you are graduate students, you're probably all facing these sorts of really difficult technical challenges right now, maybe made even more difficult by the COVID-19 pandemic. The second type of proud moment was where the individual was able to get a team moving and to change the way that the team was working together. So back to that collaborative optimizer idea, these individuals, their proud moments had to do with getting a team moving. And again, maybe you've been a part of a club, or maybe the team in your lab, you've had that opportunity to make that kind of a change. The third is realizing values. The individuals in these stories had some kind of value that they thought was really important, but that was not showing up enough in their organization. And they were able to make that difference and bring that value and make it happen in their organization and show leadership that way. And the fourth were people that were able to drive global excellence. These people were senior leaders, so they had that opportunity, but the idea of helping an organization to get to a higher level of excellence was something I think that many of you may have already had a chance to, again, in your lab or in your club. So a couple of quotes to illustrate these ideas. And I'm just going to check my time so I don't go too far over. This is professional dexterity. I did it. So this individual, in fact, I am going a bit over time, so I'm going to just skip through these, I think, but I will share my slides so that you can read these more carefully later. But this is an example of somebody who had really tackled a very difficult technical problem. He was part of a team who did it, but his sense of accomplishment was very much his individual contribution to a very difficult task. Mobilizing teams, this individual was able to get the team to actually realize something that they had been working on for a long time. Putting your stamp on it, this was an individual who made a significant change to the way that safety was being practiced by their company. He highly valued safety and was able to bring this into his company. And then driving global excellence, this was an example of an individual in higher education who was able to take his department into a higher level of excellence, so move the whole team and the whole organization.
Professor Mu, excuse me, if you need an additional time, you feel free to talk more detailed about those aspects.
Okay, great, thank you.
Please don't rush.
Okay, thank you. So I'll spend a little time here. Each of the examples that I just glossed over, in each case, they had enhanced, at the end of this, the individuals felt an enhanced sense of their socio-technical competence. They recognized that they were able to do something that was technical, but also had been able to make a difference, to make a change, whether it was to the success of the company on a technical basis or on a productivity basis, or to the difference of the team. All of them could see this link between the social and the technical. Their competence increased because they had developed this competence. It increased their confidence and it increased their sense of themselves as an engineering leader. And the leadership lesson opened up new horizons for them. So by reflecting and thinking about and internalizing their lessons, it actually opened new doors for what they were able to do. And to give a couple of quotes from some of the individuals, one person in reflecting back on their proud moment realized that what he had done in that proud moment gave him a methodology that he was still using 3 decades later. Something that had worked and been incredibly successful, he used that as a template to do more and more successful things. And then the second quote, I've integrated organizational change frameworks that I developed on site into my life. I work hard at everything. I like to change stuff. It has become my culture. So this proud moment that the individual had described, where he'd made a significant change to the way his organization worked, he actually took that and made that almost like a framework for life. So what advice can we take as young engineers who are starting your careers? How can you look to these individuals and what we've learned about leadership learning? Well, first of all, I want to encourage you to look beyond just technical learning and to get involved in activities that can help you practice these skills. As I said, leadership is something that can be practiced, can be taught, and can be learned. So you might want to take a course or do a workshop to help build your leadership skills. And these might be communication skills, practicing giving presentations, looking for tips and tricks and ways to build better personal relationships, whether that's at work or in your life. And there's a lot of great work out there on understanding how other people work so that you can work with them better. Look to other engineering leaders for inspiration and advice. And I would especially encourage you to take stock and reflect on your own proud moments and also sometimes your struggles. What have you learned? What are the leadership lessons that you're taking? And by doing that, you'll be able to incorporate your leadership lessons into your practice. And I think it will help you to be a stronger and stronger leader as you go forward. So with that, I would like to thank you for your attention, and I want to wish you all of the best in your careers as you start into what I hope will be a very long and productive engineering career full of lots of opportunities to lead.
Thank you very much, Professor Moore, for your presentation and for the research results that you showed us. It was a big pleasure for us. So we'll have time for Q&A after the next presentation, so you'll be back here soon. And now I'd like to invite Professor Elizabeth Edwards from the University of Toronto to join our discussion. Larissa, please, can you help us?
Hello, can you hear me?
Yes, Professor Edwards. Thank you very much for joining us this afternoon. It's a pleasure for us at UFP to have you both here with us in this seminar. So I'd like to give to the audience a brief introduction about Professor Edwards. Professor Elizabeth Edwards has been a professor at the University of Toronto since 1997. Her PhD was at the Stanford University in Environmental Engineering and Science. The title of the lecture she will give us this afternoon is Biozone: Few Lessons Learned in Creating a Collaborative Research Center. Professor Edwards, thank you very much one more time. So you feel free to give us your speech, and please don't rush with time. You will have additional time for a proper presentation. Okay, thank you very much.
So do I just share my screen by clicking on share screen here? Is that what I do?
There is a share screen on the bottom of the.
Yeah.
Okay.
Let's see if this works. Oh no, why is there that noise?
Okay, we can see it now.
Yeah, but I have a strange noise. Okay, there. Because you can see it now?
Yes, but it's not in the full screen mode.
I will just change that. Oops. You just saw my whole presentation in 5 minutes, in 5 seconds. Sorry about that. I have something weird about my computer. It won't. I apologize. My computer's doing strange things. Can you hear that noise?
No. You just see you and the file, but no noises.
Okay, I have to do something here. I'm sorry. I think I might, I don't know what's going on, but I have lost control of my computer. So I'm
Can
just
you,
trying
can you
to.
try again? Try to close the window.
Yeah, I'm going to. I really apologize. I think I'm going to have to log in and log out again, unfortunately.
So we'll still have some minutes before Professor Edwards come back with her presentation. So if you have any doubts or questions, please you can send to us by the chat in the YouTube channel where this presentation is now being broadcasted. Yes, so we're going to show you the institutional video of our program. So in a couple of minutes, you'll be back with Professor Edwards. Okay, thank you for your attention. Hello, we are back. So we are trying to reconnect with our guests to continue the presentations. So Larissa, can you help us? So thank you for the audience. Just one more minute. We are checking our technological platform to broadcast the presentation properly.
Hi, we just having a problem with the connection, but let's wait a little bit. And I just like to remind everyone that in the end, we're gonna have the presentations from the students, and everyone who's watching will be able to vote and also contribute with a word cloud. So don't go anywhere. We still have a lot of content today. Let's just wait a little bit for Professor Edwards. Connection Recife, Canada.
Hello, I'm so sorry. My computer just turned off completely.
Okay.
No
I'm
problem.
so sorry. Let me try and share screen again.
Okay.
Yeah, let me try and share screen again, and hopefully this will work this time. Can you see?
Not yet. Yes, it's coming now. Okay.
So can everybody, can you hear me now? Does this work?
Yes, we can see you and we can hear you, but the presentation is not in the full mode, the full presentation mode. So
Oh, really?
yes, it'll be easier to the audience see and write and read the text.
Okay. But on my computer it was, so this is very strange. Oh, I'm so sorry, everybody. These technological things. So it's not full, now is it full screen? It's not full screen yet?
For me, not yet.
So which am I supposed to, yeah, share screen.
Or if you give you much trouble, Professor, you can just try to smaller the left sidebar, and we can see the slides
Let me
bigger.
just see if I do it this way, if it's better. How about now?
Okay, now it's perfect. Thank you.
Is it the full screen? Okay. All right,
Yes,
I really
perfect.
apologize. It's okay? No.
No.
Now it is.
Yes.
Okay.
Thank you. Now it's perfect.
I am so sorry, everybody. I did not expect, my computer just overheated. Maybe I'm just on the computer too much and it just protested. Thank you very much, and I'm so sorry for the delays. And I really enjoyed Emily's presentation, and I think it's a really good segue because I lived through many of those kinds of leadership things that Emily just talked about. And I wanted to tell you the story about Biozone, and which really came up from a grassroots effort from a bunch of professors at the University of Toronto. And so the building on the bottom right is our Wahlberg building, and Savia can tell you, and some of the students, some other students from Brazil have come to Toronto and spent some time in the Wahlberg building. And if you notice at the very top, and maybe I can use my pointer here, at the very top here, there's glass windows at the very top, and Biozone involves some construction of some extra space so we could create this collaborative research center. So what is Biozone now today? Today it's an internationally recognized center for applied research at the interface of biology and engineering. And our goal and our focus is on urgent societal needs, particularly in energy and environment, but also as it links to health, and also drawing from technology that often is developed for the medical sciences and bringing that over to the environmental sciences. And, you know, I like this quote a lot, which is that the significant problems we have cannot be solved at the same level of thinking in which we created them. And so I've worked a long time in remediation, and it's very easy to spill contaminants onto the ground. It's a lot harder to get them back out. So it's a really great quote from Albert Einstein. And so the goals for Biozone are to have a positive impact on society and the environment, to work in a multidisciplinary way, drawing from all perspectives, and to fundamentally apply really good science. So molecular and cellular discoveries to important real world problems. So that's the technical side that Emily was talking about. To really uphold high caliber training and public engagement. And so these are the goals that we had set out more than a decade ago and that we still espouse today. And so Biozone was established more than a decade ago, approximately 2008, okay? And what it is space. So it's physical space, about 1,800 square meters, housing a team of about 14 professors, more than 80 graduate students, postdoctoral fellows, research assistants, technicians, working together side by side, sharing this common collaborative vision, which is to take advantage of all this innovation in genomics and AI and all the innovative biotechnology that's happening to really work in partnership with industry on problems from very basic science all the way through implementation with our industrial partners, for example. And so because of this vision, so we have equipment and space and people who are experts at all scales of a biotechnology process, from enzyme discovery and from even protein discovery and very much at the molecule scale, all the way through to full scale and process economics and assessment. So that's what it's like now. Here are the professors, some of the professors that are involved. 9 of the professors have their space physically in that building I showed you at the beginning, and other professors are in associated departments, and we all kind of work together and bring very different expertise to the problems that we tackle. And so in conjunction, as I said, what makes it a really cohesive group is that we have facilities and shared space. And the facilities are structured around very basic things that are needed. So analytical chemistry on the right-hand side, so ability to do high performance mass spectrometry and really know what's in your sample, because if you don't know the chemistry, it's really hard to figure out the technology. We also have very fundamental protein production and characterization facilities, so we can make proteins, we can grow microorganisms and extract the enzymes and do their characterization. And then we can also scale up through fermentation processes. And so that's the facilities. And by virtue of pulling ourselves together like this as cohesive groups and multiple professors under the same roof, and as well having all of our students together, then we've been able to be successful in large scale projects around mining, around biochemical transformation for green chemistry, around industrial biocatalysis, so enzymes for industrial process, around remediation, looking at benzene contamination, for example, around lignocellulosic valorization, around making chemical precursors, and so on. And these are large projects. So this is $3 to $4 million projects in Canadian dollars. So that's where we are today. But I wanted to sort of give a little bit of history of how this all came about, and just to sort of illustrate some of the points that Emily made. So way back so you heard I joined the University of Toronto in 1997. And when I came to the University of Toronto, my background was in civil engineering. Actually, I did my PhD in civil and environmental engineering, but also working for a microbiologist. So I had one foot in the sciences and one foot in the engineers. I'm an engineer by training, though. And what I noticed at the University of Toronto was there was no microbial ecology. There was really not very much microbiology other than medical microbiology. Everything was very focused on that. And so there was this gap at Toronto. And so my first idea was, well, we need to bring together, I could find some people who did environmental microbiology, but they were in geology, or they were in civil engineering, or they were in food engineering, or something like that. And they weren't really, there wasn't really a department. So then I thought, okay, well, we need to bring all these people together because we need to share ideas and so on. And so my first proposal was to write a proposal for LIMBER, a Laboratory for Innovation in Microbiology and Biotechnology Research. And I wrote a big proposal and spent a lot of time doing this, and it wasn't funded. So then I thought, okay, we tried it again. So a couple of years later, I said, okay, I won't go for quite as much money. I'll try a smaller proposal. Let's try it again. And this one I called it Environmental Bioengineering Station. And I was just looking for a little bit of money, relatively speaking, still a lot of money. And but that wasn't successful either. So then in 2007, I decided to even try for like a smaller little project, and I got a partner, a consulting company, Geosyntec, with whom I've worked with before. I got support from our department, and finally, I got $500,000 to do a little bit of work to renovate one lab and to get started. And so it took 3 tries, is what I'm saying, at this idea before it actually happened. And so then, as I said, that phase 1 finally happened in 2007, 2009. We renovated an old teaching lab to make a little bit more space for these collaborative labs, and put in some PCR machines, or polymerase chain reaction machines, which were turning out to being, at the time, starting to be a really useful technology for monitoring environmental samples. And buoyed by that first success, then we wrote another bigger grant again. Now we wrote $6.3 million grant and was successful. So that was really the second phase that really catalyzed the birth of this physical center. And then subsequently, we've been more successful. And so I just wanted to say that it took several tries and regrouping and rethinking, how we were going to pitch this before it was actually funded. And then in 2011, it was officially designated by the University of Toronto as an extra departmental unit. And I got to say that it was the chair of the department at the time, Doug Reeve, who actually also is one of the founders of iLead, who really pulled me and my colleague, Emma Master, and a few others out of the woodwork and said, hey guys, you guys are doing a good thing. You got to talk about it. You've got to organize yourselves and because I think you're doing a good thing. And so it was really thanks to their mentorship that we even thought about doing this. And the scientific principles that glued us together was, our planet and the problems that it's having in terms of climate and in terms of energy and environment and so on. And at the same time, unprecedented growth in technology for sequencing DNA. And so I know you've seen these kinds of graphs where, this is just an old one I had, but there's just so much information out there about DNA sequence, but we want to capitalize on that and actually bring it down to actionable processes and biotechnologies. The other thing that brings us together and unites us is that microbes make up the greatest source of biomass on Earth. And every time there's a new census, there's more microbes that are found in more extreme environments or deeper in the subsurface or that can do new things. And so it really behooves us to understand these microbes because they really are just packages of chemistry. And if there's any redox potential out there, then there's a microbe that's tapped into it to grow. And at the center of these chemists, these microbial chemists are enzymes, and these enzymes are highly specific catalysts that we ought to use this high specificity to create processes that don't produce as many byproducts and wastes. And so those are the glues that bring us together, but this is the problem that also brings us together, which is any genome that you sequence for any of those microbes that I told you, even our friend E. coli, that any genome you'll find maybe half to a third to a half that you might know what those genes code for. And there's usually about half of the genome or more that we still don't know what it does. And so there's this huge gap in biology of this unknown function. So what are the keys to a success for a center like Biozone? And it always comes down to people. It's people, people, people. And so the first key to success for sure is the people. And the people are all of the students and postdocs. It's also the staff and the technicians, because one of the challenges with students is that they come and go, and then anything they've learned during their PhD is then somewhat lost as they move on. So what we've learned in Biozone is that by having a core of staff who have that resident memory, it really helps transition from one project to the next across time. So on average, our Biozone hosts somewhere between 100 and 140 people, depending on the year. And it's a distribution of graduate students and postdocs and research staff, somewhere around 20 research staff, and some administrative staff and so on. And particularly people who can help you with some of the the equipment that's so difficult to use and learning how to calibrate properly and so on. And the goal is hopefully by supporting and working together that the projects that are carried out are only limited by imagination and not by access to equipment. The people come from everywhere. Brazil should be blue on there. I don't know, this is an old map, but people come from everywhere in the lab, and Toronto is a wonderfully diverse city, and it's really fun to learn from everybody from around the world. Here's an example of that. This is our anaerobic digestion team, the DAISY team. And so you can see Savia here, and also Juliana, who comes from from Belo Horizonte. And so Torsten is German, Camilla, she's from Norway, Nigel's from England, Tim is from Ethiopia, Kurt is from Estonia, Peter's from Korea. So I think all together, a really fun way of working together. And also empowering students to take on events outside of the technical side of things, charity events, science communication events, youth outreach events, thinking around challenging questions, and organizing meetings that way. Oh yes, and also we have young members too, and supporting families as well. So people are the focus, and there's a need, you know, it's so much fun to exchange ideas and share the passion, but also to have access to this rigorous training environment and to appreciate how difficult things are, to appreciate that when you give, it might not come back right away, but it comes back much later. So that to be open and willing to help others. Needless to say, there's people, there's also partners. So we've had some really great collaborations. This is a collaboration we've had with a pulp and paper mill that's north of Toronto, that is really a model for a biorefinery. They have some fantastically enormous anaerobic digesters that we've been studying, the largest wastewater treatment plant I've ever seen. You know, in dealing with trying to recoup every single part of the tree and make use of it. And so this is a wonderful partner. I've also worked a long time with a company called Serum, where we have commercialized cultures for bioremediation. And there have been huge numbers of supporters and partners over the years for Biozone. The space has been critical also to the success, having a common footprint, a place where people can get together and have lunch. We renovated, so part of the funding that we were requesting was to kind of deal with our building. So this Wahlberg building is an old building. It was built in 1949. And it had lots of tiny little rooms. And so we've tried to make bigger rooms and consolidate and renovate. And it's been quite challenging, but overall we're trying to make labs that are by theme rather than by person. So this isn't some professor's lab, it's the lab where we do enzyme characterization. This is the lab where we do molecular biology and cloning. This is the mass spectrometry lab. So there aren't labs by professor, it's labs by theme, and all the students can move from one to the other. So this is just some pictures of the construction that was done on the roof of the Wahlberg building here. We added a whole new floor. We got lots of equipment and sometimes many pieces of equipment, robotic and many PCR machines, so we could do medium to high throughput screening of biological systems. And really, the main goal here is to share your ideas right away when you have them. Share your passion, and when we have shared space like this, you have to take responsibility. So what we've been able to do over the years is organize students and postdocs and research associates into little lab teams, and they have lab duties, and the lab duties rotate around by every few months. And everybody's in charge of changing gas cylinders or racking pipette tips or cleaning up the lab in one way or another, so that everybody is part of that, and that everybody buys into reporting if there's anything that's not working. And most recently, we're really trying to espouse open science principles, publishing your work right away into the public domain, putting your data sets on public repositories, any code, anything you find, to try and accelerate the dissemination of knowledge, and to de-risk and to demystify the scientific process for everybody. So the final key to success is obviously picking a good problem, a good research problem. And this we do with a partnership with our industry and with our with practitioners. And you know, at the heart of this are microbes and enzymes, but the applications span many different disciplines. I'm not going to get into that. I think we talked a little bit about the projects. I could certainly talk more about them. Here's a little card idea again, a little picture again of the types of projects. I talked a little bit about the anaerobic digestion of organic waste, which Savia has been involved in. We have projects with energy companies to try and green their processes. We have projects for valorizing biomass, extracting nickel from our tailings in Sudbury, converting cellulosic biomass into value-added products. We also have some projects with Biozone professors that are also in health, in particular, most recently, actually with gut microbiome, because some of the work is so similar to looking at an anaerobic digester microbiome or gut microbiome, but also in health and antibiotic resistance, and also in food fortification and food engineering. So with that, I just want to summarize saying that, Biozone is really place and people, where people get together and celebrate birthdays and tackle meaningful questions together and take risks. And it's a safe place to take risks, because if there's ever anywhere that it's safe, would be in an academic environment. It's where we ought to be taking risks and having fun. So with that, I'm happy to take some questions. Thank you.
Professor Elizabeth Edwards, for your presentation and to show us the experience from Biozone. We already have Professor Moore back with us here, and we already have some questions for you. So I'll start with Professor Moore. There's a question from Professor Paulo Souza. How do you think having an engineering background can help you in leadership studies?
So I think one of the things that engineers really have in their education is an incredible ability to analyze a lot of information. Engineers are actually, that is all about what we're trained for, is not just to do calculation, but to gather lots of information, especially as you go into your sort of final year and you do your capstone project. And also in grad school, you're learning to pull together lots of different technical information and make sense of it. And that's a really important leadership skill and something that's unique to science and engineering. And many other people in, say, business leadership may not have that skill. So I think that's one thing that engineers bring. And I think that engineers also often get training on the ethics of their decision making. And especially for you all who are in civil, the best programs also are looking at sort of the context or where those engineering decisions are getting made. There's lots of opportunity to think about when a bridge is being built, who is the bridge for, who is being affected by the bridge. When a mine is being built, there's a lot of interesting social questions as well as technical questions that have to get asked. And so I think that in engineering programs, more and more, we are inviting our students to consider those and start to learn about those questions before they go into industry.
Thank you, Professor Moore. Professor Edwards, I have a personal question because as we are developing a technological park at UFPE here in Recife, and we're dealing with some complexity to put together the research incomes, the research capability and expertise from our researchers, the knowledge, together with the social demands. And from your example of Biozone, you told us about the public engagement and how to deal with the real world problems. How can you describe for us to get a line or to put in action or deal with this strong challenge to create this kind of institutional division at universities where we can put together the research expertise with the creation of solutions for the social demands?
So it comes down to people. And I think you need to know some people who are in industry. So one of the nice things about it being in an engineering department is we have a lot of our alumni end up working in industry. end up going. So at the pulp and paper mill that I told you that we work with a lot, well, some of our former students work there now. And so by connecting with them, talking to them, going to visit the mill, going to be right in, you can't ask them to come to Toronto. You have to go and physically go and speak to them, listen to what they're saying, and see how your expertise and the challenges that are there at that industry, where there's an intersection. And similarly with remediation, before I came back to being a professor, I was working in environmental consulting. So I had a lot of contacts in consulting. And I had worked there, and we had, in fact, as I was working as a consultant, I was going, oh, geez, I wish I had a lab so I could just test this in the lab. And so it was very natural that you could just build from that. And then when you start and you build a little bit, you start small. I mean, as I was trying to describe, is it didn't start as a big thing. Now people come to BioZone and they go, oh, wow, but it started with 3 people and 1 partner. And then it grew. Okay. So don't bite off more than you can chew. Start from something that's real. You have 1 good partner. That's all you need to start. I don't know, Emily, if you'd agree, but I think that's how it started. So now people come into it and they go, wow, but it's been like 15 years of little projects coming together. And finally now we can talk about it as this thing we've done, and that sells. But at the beginning, it had to be one problem that one industry really, really wanted to know, and you could probably help them.
Yeah.
Okay.
Thank you for your advice. So we still have one more question for Professor Moore. Could you give us, professors and researchers, some key instructions for starting teaching leadership at graduation schools of civil engineering?
Yeah, I think there's a couple of things. So the courses we offer to our graduate students are one of our philosophies is we're very focused on the individual learning about how they work and what they want to do. So it's very much some leadership training is learning about business or is learning about how, sort of at that level. We tend to say you can take business courses or you can, that's great if that's what's interesting, but we're very interested in trying to get people to learn more about how they work and how they best interact with others. So we actually do a lot of our teaching is we have guest lecturers come in who are specialists in personality or who are specialists in career management and can sort of help people to learn and think through what they want to do and who they are as individuals so that they can then figure out how to best lead. We don't want our leaders to all be the same. That's not the goal, but how to sort of take your strengths and find your strengths and then develop them. And I think that's one approach that we have found has worked and that the students really like. It's very accessible to the students and also very useful no matter what they do. Mm-hmm. The other thing that we do, and Elizabeth mentioned Doug Reeve, who was the founder of iLead and he's an incredible entrepreneur, an incredible leader himself. And as a professor, from the very beginning, he always created space and always demanded of his students that they had leadership opportunities. So even within their labs, he made sure, and I think Elizabeth sort of alluded to that for her BioZone today, is that there are opportunities for students to take on leadership roles, for students to organize themselves. And Doug would also give platforms. So iLead actually started because summer research students, he started a program where on Friday afternoons, they would get together and practice giving presentations, practice things like handshakes and how to network and that kind of stuff. He organized that for the summer research students because he believed that was as important as the technical things they were learning in the lab. And that's been his philosophy since the beginning. So there are relatively small things that you can do to sort of just start to open up people's opportunity to develop those skills.
Okay, thank you very much, Professor Moore and Professor Edwards. It was very inspiring, very, very nice to hear you both. It was very inspiring for us at UFPE. Both for the civil engineering audience, professors and students, but for the whole academic community. So on behalf of the university, I'm very proud to have you both with us this afternoon. So thank you very much.
Thank you for listening. Thank you for having us.
Thank you for having us. And anybody, please, contact me or through Savia or somebody if you have any further questions. I'd be happy to help. And I can share the slides.
Yeah.
Okay, it will be very nice. We still have a curious audience to see more details about your presentations. So thank you one more time.
Great.
So Larissa, can you help us now because we still have an agenda this afternoon?
Many thanks to the speakers. It was an honor to have you both here in our event. Thank you so much for all the shared knowledge. And thank you, Roberto Guerra, Director of Innovation and Entrepreneurship at our university, for being part of our event. Now we're going to go to the students' presentation, and each student is going to represent one area of knowledge of our program. So I'd like to invite, representing environmental technology, the student Felipe Filgueiras. Hi, Felipe.
Hello,
let me just give the instruction I forgot. Each student will have 5 minutes to present their research, and in the end, the audience can vote. So all of you watching, will be able to vote for your favorite, and the winner will receive financial aid to present their research in a scientific event. So how fun is that? So Felipe, the moment you start your presentation, I'll start counting, okay?
Okay, so let's do it. Hello, my name is Felipe Filgueiras, master student under advisory of Dr. Gavazza and Fernandes. And today I'm going to talk a little bit about the PAH bioremediation in contaminated mangroves. Petroleum is a complex mixture of numerous organic compounds. And from the 80s until today, ITOP and the other agencies report that although the frequency of oil spills has decreased, the volume has increased, bringing serious risks to sensitive environments such as mangroves. PAH, objects of the research, are compounds classified by the control bodies as priority pollutants, being mutagenic, cancerogenic, and here are some examples of PAHs. So, why is this problem relevant? Last year, there was a major oil spill in Brazil that contaminated more than 3,000 kilometers of the coastline. This is already considered the biggest environmental accident in South Atlantic. Despite being a problem that occurs over the world since before the 80s, there is still no consensus on the main parameters to be used to bioremediate such contamination. Additionally, few articles focus on the bioremediation of predominantly anaerobic environments, such as mangroves. As you can see in the figure that represents the dynamics of dissolved oxygen in the soil, only the most superficial layer in the region close to the roots of the trees has dissolved oxygen indexes that will provide an aerobic degradation of pH. Moreover, few articles address in situ bioremediation. Most experiments are done after collecting the sediments from the sites and creating microcosms in laboratory. The objectives of the research are to evaluate ex situ bioremediation techniques by means of natural attenuation, bioaugmentation, biostimulation, in order to enable generation of data to support the development for the Massam River. We produced a bibliographical review, provided a review of the bioremediation processes in mangroves contaminated and PAH, providing an overview such as oxygen and nutrient availability, redox potential, and the other factors of these ecosystems. The main results from these articles were bioremediation experiments that used as main electron acceptor showed better results. However, its in situ application is limited by the surface layer, demonstrating the relevance of optimizing systems under anaerobic conditions. Nutritional supplementation proves to be relevant, although more studies are still required about the interference in efficiency. Microbiota analysis reported in the articles are punctual. The evolution of microbial consortia during the bioremediation process or the metabolic routes involved in the biodegradation process are not covered by them. And this figure is a graphical abstract that represents the flux of information used along the article. So, as final remarks, we have that there are still several questions to be answered regarding pH bioremediation in mangrove sediments, and that future works may address the relation between metabolic routes of microbial consortia in situ and ex situ. And this bibliographic review article will help us to develop and establish an experimental procedure for the entire research. So, thank you all.
Thank you so much, Felipe. Great work. Let's now have José Haurion. Let's invite José Haurion from the area of water resources.
Olá.
Sorry, I'm from water resources, but Haurion, when you start, I'll start the time here, all right?
Ok. Deixa eu compartilhar aqui a tela. Estão me vendo? Estão vendo a tela?
Estou vendo.
Pronto, ok. Boa tarde a todos. Oi.
Haurion, estou vendo você, mas não estou vendo sua tela.
Não está vendo a tela? Ah, tá. E agora?
Agora sim.
Pronto. Bom, boa tarde a todos. A nossa pesquisa trata da caracterização volumétrica de reservatórios através de dados altimétricos associados a imagens ópticas. Como introdução, a gente sabe a importância das águas superficiais, né, para todo o processo do balanço hídrico climático, e o estudo da batimetria, né, é um elemento essencial para um melhor atendimento da modelagem. Nesse sentido, a nossa metodologia aplica o sensoriamento remoto como alternativa à batimetria tradicional. E nós aplicamos isso em dois reservatórios, né, um muito grande, com 34 km cúbicos, e outro pequeno, para avaliar o emprego da metodologia nesses dois reservatórios. Como uma síntese dos problemas, né, e a área de estudo, a gente tem a questão de que a batimetria tem um custo elevado, depende de vários fatores, como localização, extensão, o acesso ao local, o tamanho do volume, varia o preço. A gente tem um problema de falhas de dados de monitoramento. A maioria dos reservatórios nossos não tem dados, né? E, por último, a gente tem uma resolução da ANA e da ANEEL, a Agência Nacional de Águas e a Agência Nacional de Energia, 2010, que requer a atualização da curva cota-área-volume a cada 10 anos. Então, a gente percebe aqui, nessa área de estudo, né, aqui o reservatório de Sobradinho, aqui o reservatório de Poço da Cruz. Aqui a gente tem as estações que foram utilizadas, e essa malha aqui são a malha vermelha, os dados da passagem do ISAT-2, um satélite altimétrico, e em verde as passagens que foram selecionadas no estudo. E aqui a gente tem a bacia do Rio São Francisco. A metodologia consiste basicamente na associação das imagens ópticas. A gente tem todo um processamento das imagens, desde os rastros, a classificação do NDWI até o contorno hídrico final, e as fontes altimétricas, então a associação da parte de altimetria e planimetria. Então a gente aplicou esses dois dados, a dado de altimetria e de óptico, e no final a gente tem uma nuvem de pontos 3D, onde tem a latitude, longitude e o nível coletado. Aqui tem a passagem do ISAT, e quanto mais baixo o nível que ele passar, melhor, porque a gente pega uma maior abrangência de contornos hídricos. Aqui tem um perfil longitudinal desse raster que passa esses pontos aqui, e aqui a coleta das elevações. A gente tem aqui os resultados, onde a gente vê o MDT gerado, com o nível observado, a gente conseguiu 84% de cobertura do reservatório. Aqui a gente tem a cota área-volume, né, que deu um volume na cota que praticamente é 99%, em 8,21%, uma subestimativa. Compensação, o trabalho de Lopes calculou ao longo de 32 anos, em 2015, que estava com a redução de 8,25%. Então, praticamente bate com a batimetria de Lopes. E o ISAT conseguiu aqui uma cobertura de 50%, também um bom ajuste na curva cota área-volume. Aqui a gente tem Poço da Cruz, que praticamente cravou o volume, com a diferença de 1,18%. E como considerações finais, a gente tem que a metodologia, né, ela apresentou-se economicamente viável, é uma alternativa que usa dados frios, né, e consegue uma resolução, uma batimetria 3D de alta resolução. Os dados ISAT-2, por sua vez, eles surpreenderam realmente nesse nível aqui. Se a gente compara com o nível monitorado, ele deu um erro até menor, de 4,17%, enquanto o monitorado deu 7,7%, e Poço da Cruz atingiu um erro diminuto, como eu falei, de 1,18%, praticamente cravando o volume. Né? Isso possivelmente, né, porque a batimetria de Poço da Cruz é uma batimetria atualizada, foi feita recentemente, e aí a gente percebe que esse erro pequeno é em função disso. Provavelmente, em Sobradinho, nós teríamos um resultado melhor se tivesse uma batimetria mais recente, como a gente comparou com a de 2015 de Lopes. E como a limitação da metodologia, nós temos que os volumes abaixo da variação da superfície, abaixo da fonte altimétrica, a gente precisa desse dado previamente. Muito obrigado.
Thank you, how are you? Thank you so much. I think I explained a little too fast. To all of you who have been to our event before, and to all of you who are new, today we're gonna have, this is a 5 minutes competition, all right? And next Monday, November 23rd, we're gonna have a 3 minutes competition. And you can all vote. I believe the link is already on the chat, so you can all click there and vote for your favorite presentation. The winner will receive a financial aid to participate in a scientific event. Now, I'd like to invite, from the area of geotechnics, Guilherme Gomes. Hi, Guilherme.
Hi, good afternoon. Can you hear me?
Yes.
Yes. Let me share. Okay. Can you see my screen view?
Not yet.
And now?
Now it's okay.
Okay.
So when you start, I start the time. Don't worry.
Okay. Can you start? Now?
You can start whenever you want.
Okay. Good afternoon, all. My name is Guilherme Gomes. I'm a master student of geotechnics. Yeah?
Não tá no...
No,
Não tá aparecendo tela cheia.
Tela cheia. Deixa eu só um momento aqui. Deixa eu compartilhar minha tela, que é melhor, né? E agora?
Não, só tá aparecendo você. Agora. Wait a minute. Bom, se você quiser ir fazendo assim...
Tá pequena a tela, é?
É, tá aparecendo o PowerPoint completo.
Deixa eu só habilitar aqui. E agora?
É.
Agora tá melhor?
Não, agora eu só tô vendo você.
Mas a tela tá inteira?
Não, eu tô vendo você só. Não tô vendo sua tela.
Rapaz.
Compartilha de novo.
Tá o PowerPoint. E agora? Tá todo? Tá todo?
Agora.
Todo.
Alright. Quando você começar...
Agora tá ok?
Agora tá ok.
Thank you. Let me start, okay? My name is Guilherme Gomes. Sorry for this. And I'm a master student of geotechnics. My supervisor is Dr. José Fernando Tomé Jucá. And I'm going to present you the analysis of landfill cover soil, made with organic compost for biocover design. Okay. First of all, the dump sites are responsible for 40% of the waste in the world, okay? And the biodegradation of the dump site in these places generates a lot of subproducts. And one of these subproducts is methane gas. And the methane gas goes to the atmosphere and potentialize the greenhouse effect. And another product in this place is leachate. The leachate is generated by rainfall water that infiltrates into the waste and goes to the subground water, surface water, as you can see in this figure. And all of these cause a lot of problems, environmental, social, economical problems, okay? But one engineering technique is a landfill. Landfill is a technique that you isolated the waste from the environment by applying a liner system on the base, on the foundation, in a cover system. And besides that, you can apply drainage systems that collect the biogas, the methane gas, and the leachate, okay? But as you can see in this figure, the drainage system is not capable of collecting 100% of the biogas. And the cover system is very important in this case, okay? By retaining this uncollected portion of the biogas. But in any case, the biodegradation of the waste cause volume reduction, and these induce some settlements, differential settlements on the surface, and the cover system is subject to cracks on the surface. And besides that, there are some interactions between the atmosphere with the cover system that can, like temperature and moisture effect, causing wetting and drying cycles, okay? And all of these compromise the functionality of retaining biogas from the cover system, okay? Biocovers may be implemented as an alternative, because a biocover is a cover that the soil cover is completely changed or partially changed by an organic material. This organic material provide increase the water holding capacity of the cover system, and this is very good for preventing the cracks. And this organic material has some microorganisms capable of oxidizing. It has a function of biofilter that is oxidize methane gas, okay, from the waste. The brief problem description here, we need to know that some environmental protection agencies around the world require some values of hydraulic permeability, water permeability, maximum values of 10 to the minus 9 meters per second, and intrinsic gas permeability, a minimum value of 5 times 10 to the minus 13 square meters. And in this study, we applied a mixture composed by 50% of a soil used in a cover system, Mulibeca Solid Waste Landfill in Jabotão dos Guararapes, Brazil, and 50% of organic compost provided by a window composting company in Recife. Okay, and the results show us, the figure 6, that we achieved initial compaction acceptable zone for this material in the field. And the figure 7 shows us the possibility that we can calculate the minimum compaction energy that applied in the field, okay? The figure 8, as you can see, we applied the Wangen-Nuchten model for this material, and we estimated the allowable range of suction and compact and gravimetric water contents in the field that be in accordance with these literatures and these environmental protection agencies. Okay. According to those, yes.
Your time is up. Sorry.
Sorry. Okay. Thank you.
Well, thank you so much for your work in your presentation.
Just 1 minute. No?
I can't, sorry.
Okay.
Thank you. And I'd like to invite Katarini from transport, the area of transport.
Hi, are you hear me?
Hi.
Trial version. I'm sorry, I couldn't connect my camera. I tried, but
it's okay. Trial version. Share your screen.
Trial version.
Are you able to share your screen?
Trial version.
I'm trying.
Right.
Trial version.
Do you see?
Yes.
Do you see my screen?
Trial version.
Okay.
Okay. So let's
trial
start.
version.
I am Katarini, and I will present to you my research in a physical integration-based
Trial
public
version.
transport network. Technology is a reality in our daily life.
Trial version.
And in public transport systems, it is not different. Many of these systems use
Trial version.
smart cards to collect fares and have automated vehicle location devices.
Trial version. Trial version.
Intelligent transport systems are widely discussed, and their main objective
Trial version.
is to apply information and communication technology to improve the transport
Trial
system
version.
performance. Despite all this technology available, the
Trial version.
definition of timetables for public transport lines still relies on the
Trial
planner
version.
experience and basic statistics. Computational
Trial version.
intelligence approaches, such as machine learning algorithms, can contribute
Trial
to
version.
overcome these issues. There is a course in literature
Trial version.
addressing the use of machine learning to optimize integrated public. Hi.
Trial version.
Katarina, I'm so sorry to interrupt, but we are having a little noise here. It's not you. Let's just we're gonna fix it, all right? Just a little bit.
Okay.
Trial version.
I think everyone is listening to trial version. Okay, stop.
Trial version. Trial version.
Let's just try to find out what is going on.
Trial version. Trial version.
Katarina, it's from Katarina's.
Trial version.
Can you try, Katarina? Can you try get out and log in again? We're gonna move on to Mateus, and then you go back to your presentation.
Trial version.
Okay. So
All right.
I'll
There's a sound coming from your computer.
Trial.
Okay, let's try with Mateus. Mateus Brunet. Are you ready?
Start. Give me a second.
Hi, Mateus.
How are you?
Representing the area of petroleum.
Yes,
Please.
of course. Give me a second. I'm going to share my screen. Okay, I'm ready. Let me share in full screen.
All right. When you start the presentation, I'll start the time here, all right?
Can I start?
Yes.
Okay.
Anytime.
Okay. Hello, everyone. Can you hear me? Yeah? Hello, everyone. My name is Mateus Brunet. I'm a petroleum engineer and Master of Science student in Reservoir Simulation at Federal University of Pernambuco. And I'm here today to present you part of our research that's titled Coupled Hydromechanical Modeling of Water Flooding under Fracturing Conditions using Special Interface Elements, okay? So this presentation is basically divided in 5 sections: introduction, objective, methodology, numerical study of fracture propagation, and conclusion, okay? Okay, water flooding is a secondary recovery method widely used in the oil and gas industry to maintain reservoir pressure during oil production or to restore the pore pressure after depletion. So the injected water works like a piston by pushing the oil present in the reservoir in the direction of production wells. one of the problems related to water flooding is called injectivity loss. And a possible solution to the problem of injectivity loss is the injection above fracture pressure. And this specific case, a fracture grows slowly in the reservoir. Okay, so this is an important alternative, but it's necessary to predict the fracture behavior in order to avoid a reduction in reservoir performance and environmental problems, such as fracturing layers close by. Okay, so the studies proposed in this work aim to model the hydromechanical behavior of the fracking in the presence of production wells and analyze if the interface elements can represent fracturing opening and propagation on the injection above fracture pressure conditions. So the numeric analyses were performed using a finite element code that performs numeric analysis of fluid flow in a deformable porous medium in a fully coupled scheme, okay? And in order to represent the fracturing process itself, we use what we call special interface elements and a tensile damage mechanics approach, okay? Here we just have basically a simple way to understand everything that happens, okay? At the left-hand side, there is a small section of original mesh on the forming mesh. So the regular elements are in white, and the special interface elements are in a light orange, okay? So the special interface elements are very thin elements between the regular elements, okay? So they hate sum of zero. And initially, both of them, regular and interface elements, are representing porous media. So both are representing the rock matrix itself. An elastic rock, to be more specific, okay? At the right-hand side, the time has passed, the fracture has propagated. So the regular elements are representing porous media. But the highlight here is related to a special interface element, okay? Because when the stress reaches the rock tensile strength in these elements, the material is degraded. And now the special interface elements don't represent the rock matrix anymore. They are representing a fracture, okay? Here we have an example of an injection above fracture pressure operation. The problem here is a half of an inverted 5-spot. So we have one injection well and two production wells. And here, an anisotropic stress state applied. Okay, so at the bottom, we have the analyses. And the first one is the injection rate effect on fracture propagation. Okay, so in this case, the production pressure was fixed. Then in each case of this analysis, a different injection rate was applied. Okay, and the second one is the production pressure effect on fracture propagation. In this case, the injection rate was fixed in 90 cubic meters per day. Then in each case of this analysis, a different production pressure was applied, okay? Here we have the results. At the left-hand side, we have the injection rate effect on fracture propagation. And at the right-hand side, we have production pressure effect on fracture propagation. So we have fracture length versus injected volume, injection pressure, and pressure field. The results of these analyses show that hydraulic fractures formed in water flooding operations can reach hundreds of meters in length. The results also reinforce that hydraulic fracture length is strongly affected by fluid diffusion and average reservoir pressure. And it was possible to confirm these results by changing injection rate and production pressure. And finally, the results validate that the special interface elements using the constitutive model of tensile damage mechanics can capture the central aspects of hydraulic fracturing in the presence of production wells, which typically occurs in injection above fracture pressure operations. So I'd like to say thank you very much to our Brazilian councils, CNPq, Energy Simulation, and Petrobras. And thank you very much for watching.
Thank you, Matheus. Great work. Let's just wait a little bit, see if Catarina is able to come back. Did you guys vote already? Have you guys subscribed to the channel, please? Let's see. Catarina?
Trial version.
Oi. Can you see my screen?
Trial version.
Try saving. Tenta salvar em PDF.
Trial version. Trial version. Trial version. Trial version.
E fecha o PowerPoint.
Trial version.
Não, não escute não.
Trial version.
Let's just wait a little bit. It's technical issues. It's okay. Have you guys vote already? I'm gonna keep saying this.
Trial version.
Okay, so now we can see. Okay, let's just see if Catherine is able to present. Otherwise, we're gonna go to the results. Okay, everybody, let's just wait a little bit more.
Eu acho que ela não está me ouvindo.
Trial version. Trial version. Trial version.
Two. Once again.
Trial version.
Can you see?
Wait a minute. Yes.
Trial
I can see it.
Trial version.
Did you close PowerPoint?
Yes.
Trial version.
We're still listening to trial. Are you listening to this warning?
Trial version.
I am not.
Trial version.
Let me see what the backstage tells me.
Trial version.
Let's see if we move to voting. You can try and vote. Let's see. Try Catarina once again, or if you go to voting. Okay. Let's try one more time. Catarina.
Version.
Hi.
It is
Trial
something
version.
computer.
We can
Trial version.
find where.
Trial version.
Okay.
Trial version.
Catarini.
Oh.
Present
Trial.
without the close all the programs and just
Trial version.
try and
Trial
Agora
version.
o som parou para vocês.
No, I'm listening.
Trial version. Trial version. Trial version.
I'm so sorry. Let's just figure out what to do now. Okay, we move to voting. What do you guys think? Okay, unfortunately, I'm sorry, everybody from transport area. these things happen. Let's try and see if you can see the numbers, all right? Karine, please. Longer than the... Okay, so the result... Wait a minute. Is it a draw? Two winners? What? You guys see it? Okay, it's very small to me. I don't know the names here, but anyway, congratulations, everybody. Congratulations to the winners. To the winner, is there a winner? Yeah. No. Oh. Anyway. I'm gonna have to figure the election system better, right? Okay, look, we'll figure this out. Some technical issues, some unpredictability. Let's just, Monday, November 23rd, we have another afternoon, afternoon of events. So we're gonna figure this out and see how we can solve this, all right? Don't worry, we're gonna talk to all of you guys. So that's all for today. We'd like to thank everyone for participating, speakers, students, professors, researchers, everyone who watched it. Thank you so much. And remember, we're not finished, we're not over yet. I'm waiting for you next Monday, November 23rd at 3 p.m. We are going to have some great lectures, some research presentations, and more content on science, entrepreneurship, and leadership in engineering. So that's it. Have a good night. See you Monday. Bye. Oh, yeah. And if you want to give your opinion, there is a link. There is a link to you guys give your opinions and suggestions and critics and everything. Thank you very much for having us. Thank you for being here. Thank you for watching. See you Monday. Have a good night.